Welcome to this beginner-friendly guide on implementing enemy spawning and difficulty scaling in Unity 3D. In game development, dynamic enemy spawning and adaptive difficulty are crucial for engaging gameplay, keeping players challenged and invested. This tutorial will walk you through the step-by-step process of writing C# scripts in Visual Studio and applying them within the Unity 3D engine. First, let's set up our Unity project. You can either create a new project or use an existing one for this tutorial. Next, create a new scene and establish a basic game environment, including a ground plane and a simple player character. Familiarize yourself with Unity's interface. The scene, game, hierarchy, project, and inspector windows are your primary tools. Now, let's prepare our enemy. Create a simple 3D object, like a cube, sphere, or capsule, to serve as your enemy model. Add a rigid body component for physics interactions and a collider component for collision detection to your enemy object. To reuse this enemy, create a new folder named Prefabs in your project window, then drag the enemy object into it to make a prefab. Next, we'll write the spawner script. Create a new C# script called Enemy Spawner and attach it to an empty game object in your scene. Open the Enemy Spawner script in Visual Studio. We'll define a public game object variable to hold our enemy prefab. Also, define a public float variable for the spawn interval, which will control the time between each enemy spawn. Inside the spawn enemy function, we use instantiate to create instances of our enemy prefab at a specific location. We'll use random.InsideUnitSphere to randomize the enemy spawn position, ensuring enemies appear in varied locations. Finally, invoke repeating will call our spawn enemy function repeatedly at the defined spawn interval. Here's the complete code for our basic enemy spawner script. Pay close attention to the variables and function calls. Back in Unity, drag your enemy prefab from the project window to the enemy prefab slot in the enemy spawner component. Adjust the spawn interval variable in the inspector to control how frequently enemies appear, then test your basic spawning. To make spawning more dynamic, let's modify the enemy spawner script to spawn enemies at random positions within a defined range. Define public float variables for xmin, xmax, zmin, and zmax to set the boundaries of your spawn area. Then, use random range to generate random x and z coordinates for the spawn position within these defined limits. Here's the updated enemy spawner script with random position logic. Notice how random range is used for x and z coordinates. In Unity, adjust the xmin, xmax, zmin, and zmax variables in the inspector to define your desired spawn area. Test the game to observe enemies spawning randomly within the boundaries you've set, adding more unpredictability. Now, let's implement difficulty scaling. We'll start by increasing the enemy's spawn rate over time. Modify the enemy spawner script to decrease the spawn interval over time, making enemies appear more frequently. Use invoke repeating to call a new function, increase difficulty, which will periodically reduce the spawn interval. Next, let's make enemies faster. Create a new C# script called Enemy and attach it to your enemy prefab. In the enemy script, define base speed and speed increase amount variables to control the enemy's initial speed and how much it increases. In the update function, increment current speed by speed increase amount multiplied by time.delta time for smooth, time-based acceleration. Here's the modified enemy spawner script, now incorporating difficulty scaling for spawn rate. And this is the enemy.cs script, which handles the enemy's movement and speed increase over time. In Unity, adjust the difficulty increase interval and spawn interval decrease amount in the enemy spawner component. Also, set the base speed and speed increase amount in the enemy component on your prefab to control enemy movement. Test the game to see the difficulty dynamically increase as enemies spawn faster and move quicker. To introduce more structured challenges, we can implement enemy waves. This allows for controlled spawning patterns. Create a new C# script called Wave Spawner to manage the spawning of enemies in distinct waves. Define a wave class or struct to store information for each wave, such as the enemy prefab, count, and spawn interval. Use a list wave to store all your defined waves and implement logic to spawn enemies based on each wave's information. Here is the complete wave spawner script. demonstrating how to structure waves and manage their spawning. For beginners, always use comments in your code to explain complex logic or important sections, improving readability. Test your game frequently to catch errors early. Small, iterative tests save significant debugging time later on. Start with simple mechanics and gradually add complexity. This approach helps manage scope and prevents feeling overwhelmed. Utilize Unity's extensive documentation and online resources. They are invaluable tools for learning and troubleshooting. Finally, optimize your code for performance. Efficient scripts lead to smoother gameplay and better user experiences. We've covered basic and random enemy spawning, difficulty scaling through spawn rate and speed, and even enemy waves. Now, experiment with these concepts and build upon what you've learned to create unique and engaging game experiences. Consider exploring advanced AI, pathfinding, or different enemy behaviors to further enhance your game development skills. Thank you for watching this tutorial. Keep coding, keep creating, and have fun developing your games.